previous lesson, I left you with an assignment. So hopefully you got some practice on creating animal classes and objects to roam around in our zoo. So I'll go over that solution right now. Here's my animal class, and I gave it the attributes such as age, gender, and weight in pounds. So all of our animals will have these attributes. And I gave the instructions for how the animal should be created by using a constructor with arguments being passed in here. So when we create the actual object, we have to give the arguments, and those arguments will be assigned to the fields in this class. I also defined two behaviors that all animals should have. They should be able to eat and they should be able to sleep. So again, I'm going to keep drilling on this point. A class is a specification. It's a blueprint or a design, in this example, how animals should be in our application. All right, so coming to the zoo class, in here I defined the main method. And remember that this is the starting point for our Java application. So let's create an animal, and I'll just call it animal1. It's not important to get into the details of what we want to call that variable. New animal. All right, so I've created a variable, animal1, of type animal, and we want to assign the created object to this variable. Recall that we can't really use the default constructor of the animal class because we've defined specifically what constructor we want to use. Right? These are instructions for how a proper animal should come into existence in our application. So we need to pass in values in the constructor method right here. So it expects an animal to have an age. So we'll give that. We'll call it a male. And the weight in pounds, we'll just say it's a 23-pound animal, whatever animal it is. And now we can invoke methods on this particular variable, like that. So this variable actually points to the object that was created in this line, and then we ask that variable to, hey, make the object that you're pointing to execute this particular method. Right? That concept is a bit abstract right now. I know it's a little confusing to you. Don't worry, it will clear up pretty soon, especially after practicing some more problems in the course. I also asked you to be a bit creative and create other classes, the fish class and the bird class. So let's create those. Fish. And in this class, we're just going to have one method. I'll keep things simple. Public void swim. Fish are able to swim. And I'll leave it a simple implementation saying swimming. All right. So again, this is a specification for fish in our application. Every object that we create from this particular class will have the behavior of being able to swim. Now let's create the other class. We'll create the bird. And I'll define a simple method in here, say fly. And we'll just say that it's flying. Again, this is a specification. I know I keep repeating this, but this is so important for you to intuitively understand that this class is a specification, it's a design, and all objects that we create from this class are going to have the behavior and will know the instructions from this particular class. So back in the zoo, let's create a bird. Bird 1, I'm not going to give any names. New bird. And notice that we don't have to pass in any arguments in here because I haven't defined a specific constructor. Remember, every class has a constructor by default. If you don't define one, it actually has one that looks like this. This is there by default if we don't specify a constructor. Now in the zoo, back in the zoo class, I created a variable of type bird that points to the object that was created, and then I do bird1.fly. Now, if we run this, it's going to behave as expected. This eating behavior is from the animal class, and the flying behavior is from the bird class. All right, so as you tried that out, hopefully you got this far on your own. Now let's quickly review how Java code is organized, because before moving further, I think that's an important point we should cover. This diagram explains how Java code is organized in general. Java code, for the most part, consists of classes and methods. And these are basically Java files. They're files with the extension .java, and they're usually contained in folders referred to as packages. So here in Eclipse, we have a package. This is actually a functionality in Eclipse called the default package, which is really not where you want to put your code. You want to define a specific package. So I'll just right click here, go to new, and then you can go to package, and then you can create the package and then put the classes inside that package for better organization. So classes basically contain methods which have all of the behavior defined, and the classes are basically a blueprint or a specification or a design, and we use that blueprint to create the actual objects. Now, I know we kept making the distinction between what a class is and what an object is. That's a very important distinction to be made early on, but it's time now to get a deeper intuition about what objects really are. What exactly do you think is an object? You already know that we use the constructor of a particular class to construct objects of that class. So for example, when we created Tom and Joe in the previous lesson, they were both instances of type human. But when exactly did those objects come into existence? Strictly speaking, it's not exactly correct to be calling the variable Tom or this variable bird or animal1 an object, because objects are a runtime concept. They don't actually exist until the application runs. So in our Eclipse, if I hit this run button, again, remember this is the entry point for our application, so it's going to start here executing the program. It's going to go line by line, and when it gets to here, it'll first create a variable of type animal. It'll allocate space in memory for that particular variable, and then somewhere else in memory, it's going to create the actual object, right? And this variable, animal1, is going to point to the memory address for where that object is actually located. So when we invoke the eat method on this variable will be able to tell its object, it's going to say, hey, object, I know where you're located in memory. Do this for me. Execute the method eat. And remember that the eat method's behavior is defined inside of the animal class. What is it going to do? It's just going to say that it's eating. It's going to print that out. It's going to print that to the console. So similarly, as the program is executing, it's going to move on to the next line. It's going to come onto this line where we are creating a new object of type bird, right? And we have this variable called bird1 that is going to point to the location in memory where the actual bird object is created. And then this variable is going to, when we invoke the fly method on this variable, it's going to be able to tell the object in memory to execute the fly behavior. And that fly behavior is, of course, defined in the bird class. Right here, it's just going to say, it's just going to print flying to the console. So again, because objects are a runtime concept, they don't actually exist until the application runs. So before hitting the run button here in Eclipse, all we have are files with Java code in them. That's just a way of organizing our code. So basically just files containing instructions all over the place for how our program should operate when we actually run the application. So there are no objects at this point, right? The application is not running. There are no objects at this point. When we run the actual application, the objects come into existence, so they're born, so to speak, and only then do they carry out their behavior and do things in the application. Now, this is a subtle but an important point. Beginners in object-oriented programming think about the classes and methods they would need to write, but more experienced developers think in terms of runtime and how objects will behave while the application is running. If I keep talking like this, you'll soon transition into this way of thinking as well. But for now, it's enough to just understand that when we run our application, memory resources get allocated to contain the objects of our program. And the instance variables, these are also referred to as instance variables, these variables point to the actual location for where those objects exist in memory. And through these variables, we can actually ask those objects to do things, such as fly and eat. And they get this behavior through the variable type, which is an animal. And we have that behavior defined in animal class to be able to eat and sleep and so on. All right, so I tried to repeat this concept multiple times in a couple of different ways so that you can hear it in different flavors. And I hope that you have a deeper understanding of objects in a Java application. But if it's still a little confusing for you, don't worry. We're going to be coming to this later in the course, and by then it'll make a lot more sense.